So we're going to look at a straightforward activity that reinforces the makeup of different elements on the periodic table. And so what we're going to do, we're just going to add the number of protons in each particular element. Number 2 is just off to the top right. So number 1, top left, was hydrogen. And then we come on to number 3, which will be lithium, element number 3, and has 3 protons. So as we're going to go across this second row, period 2, beryllium will have 4. And we jump over the artificial gap. There's no gap between beryllium and boron, elements 4 and 5. So boron element 5 has 5 protons. Carbon, elements so important to life, has 6. They seem to be rolling away a bit. And we're just continuing to add 1 more proton as we go across a row from left to right. So the next one will be oxygen with 8. And so really all we've done is increase the number of protons by 1 as we go across the periodic table. And the atomic number, indeed the number of protons in the nucleus of an element, is the reason for a particular element's position in the periodic table. We'll talk about the vertical groupings and chemical similarity later, as to why we just don't make one big strip. And so we've got the noble gases, which are just off screen to the right, and we'll come back with element number 11, which is sodium, and start the third row, period 3 of the periodic table. It's also worth mentioning here that we aren't showing the neutrons. So each element has perhaps a number of isotopes, so can have atoms with different numbers of neutrons. And again, we'll talk about those a little bit later. So we've just completed sodium, first element of the third period, with 11 protons. And then we're going on to magnesium, below beryllium, which had 4. So at the moment there's a difference with 8 protons as you're going down, but that only works for the second and third periods. And so element number 13 is aluminum, and we could continue, keep adding 14, 15, 16, 17, 18, and finish that third row, and then go on to the next row. But what we're going to do here is just put number of protons in for iron. Sorry, I think that one must be nickel, number 27. So with 27 protons. And we could go all the way through the periodic table right up to